So we're going to talk about designing the futures. From the video, the opening video, we learned that the world is indeed facing serious challenges from urbanization, climate change, population growth, and recently the migration of people from the conflicts area, and also the disease outbreak like Zika. In solving this complex problem, it is inevitable that we really need to work across sectors, industry, and disciplines. And we need a system that allowing collaborations, allowing sharing idea, and allowing to design together. Okay. Only that way, then we can create a solution, a sustainable solutions to the problems. We know GIS is a system of engagement. We know GIS is a system for collaborator. We know that GIS leverage our best science, technology, and design. So we're entering a new era in GIS, which is the era of GeoDesign. It's combining the power of GIS with the design process. GeoDesigns provides the frameworks to infuse designs with a blend of science and value-based information to help designers, to help the stakeholder and planner to make better decisions. GeoDesign allowing us as the GIS professional, you and I, to provide the content and also the analysis to the planners, who then use their expertise to create a design. When I talk about the planners, it's not about only city planner and urban planner. It's all that people that contribute to the design. It can be from other departments within the organization, public work, health, utilities, or even outside the organizations, people from the academic and the community at large as well. Working together, collaborate, to create a design that works for everybody. Let's take a look at a few examples of GeoDesign. GeoDesign has been used for the solar energy potential analysis in many cities. Here is in Massachusetts and North Carolina. Urban design and urban development are the sector that intensively use the GeoDesign. An example in here is from Rochester, New York, and Riyadh, Saudi Arabia. But we don't have to go far. Here in Singapore, one of the best examples for urban development and urban design. You're going to hear from the speaker after me from URA. Urban design also used for, the GeoDesign is also used for planning park and open space. I like the one from the Trust of Public Lands, Lanier County, Colorado. It creates an app that's allowing to have the slider so the citizen then can play with different scenarios and what they like their open space look like. So that's a good example involving community in GeoDesign. GeoDesign has been used in agriculture and biofuels. University of Minnesota used GeoDesign application to weigh the impact of various crop planting to create the multifunctional landscape design to optimize the benefit of biofuel production and in the same time protect the water quality and the natural area. GeoDesign is widely used for modeling climate change, the sea level rise, storm surge, and to ask the question why where to build is equally important than what to build. GeoDesign is also used a lot for the conservation and biodiversity. What I like the most is this one. This is an example of geodesigning, which involved the village community in designing the reconstruction project after the earthquake in Nepal. To make it easier to implement GeoDesign, Esri provides GeoPlanner for Arcgis. GeoPlanner blends the power of Arcgis as a platform coupled with the GeoDesign workflows. And it can be used for a wide range of industry. It incorporates common geodesign workflow from the project creation, data discovery and use, suitability assessment, create the scenario creations, evaluation and comparison of alternative design, and also reporting. And all of this combined into a single web application that allow users to collaborate from anywhere, anytime, using their PC or tablet. This application can save organization time and money through the improved collaboration, deliver better result. Now I'm gonna take a few minutes to illustrate the power of GeoDesign using a planning scenario in GeoPlanner for Arcgis. What I'm gonna use in here is the hypothetical scenario from San Diego. So the San Diego, to respond to the rapid growth of the city, is planning to have a new bus rapid transit road, or BRT. So we're gonna take a look, we're gonna compare two design scenarios. We're gonna leverage GIS suitability model in making decision. We're gonna perform analysis on populations and job within the proposed BRT platform, and we integrate with another apps. So let's take a look. This is the GeoPlanner for Arcgis with the downtown San Diego. To help the planner, the GIS teams has provided some data, such as the bus stop and bus route, the light rail track, and the light rail platforms. Let's take a look at the first proposal for the BRT route here. This is the proposal A. Go through the city of the downtown from the Balboa Park. Visually, it looks like a nice alignment. It has a connectivity with existing bus transit stations and also the light rail platform. But can we actually do more? Can we actually incorporate more criteria into our selection here, to our assessment? We can leverage the model from GIS that we're familiar with. It's called Suitability Model. Now, the suitability models take into consideration several criteria. For my model here, I'm going to use 4 criteria: the closeness or proximity to the bus transit, development potential, light rail proximity, and population density. And each of these criteria, we built the scoring system. So for the bus transit proximity, the closer to the existing bus stations, the more desirable for placing our new BRT alignment. The same as well, we do it for the light rail proximity. The closest to the platform of the rail, light rail, the more desirable. Populations. It's very obvious. The more people, the more dense the location, the higher score that we give, the more desirable. The development potential is slightly different here. The city of San Diego would like to also use this BRT platform to simulate the economy development. So in here, we use the attribute called FAR, is floor area ratio, which is the calculate based on the total floor area of the building against its the size of the lot itself. I think most of you planners are probably familiar with the FAR. So the higher the value, it seems like the more dense the area, the more floor, and it seems like more usage and more people. So we give the higher score as well. Individual criteria in here, we can also give different weight. Seems like people in San Diego like to walk into the light rail station instead of the bus transit. So we're gonna give more weight into the railroad and less into the bus transit. And we're gonna run this model in here. When I run this model, behind the scene, it's actually calculated very sophisticated the weight, raster weight overlay. But for the planners, non-GIS user, they can just use the GeoPlanner easily to run this model. So this is the result of the model. The green area is the most suitable. The yellow one is somehow suitable, and the red one is not suitable. And we can take a look our proposal, propose A, and how the alignment is actually missing some of the most desirable area. So as the planner, we can then adjust our proposal in here for the alignment, and we create another proposal, which I did already. This is the proposal B here. Okay. So we follow the result of the analysis. Now we take into consideration more the area that most suitable. Let's evaluate this a little bit more by compare it side by side. So in here, I'm gonna have the, oops, a little bit too far, proposal A and proposal B here. So visually we can see, but the dashboard we can help us to compare quantitative the result of our selection of the alignment in here. For the proposal A, it seems like we have 25% have the score 7, and 25% score 6, and majority 50% is score 5. Let's take a look at the proposal B. 40% is actually get the highest score of 8, another 40% score 7, and only 20% of score 5. That means that we have more confidence in selecting which design that we want to choose. Okay. GeoPlanner allow you to have alternative design, do iterations, and do more assessment by comparing one alternative to another. So we set now with the alternative B here. So I'm going to close this one, and then we go to the alternative B. It is important as well to assess the impact of the new alignment and the BRT road with the existing area in here. So what we can do is actually we can calculate the area where how many people, the distance that people walk into the platform. This one is the result of the distance of the, let me just turn off the suitability here so you can see it better. So this one is the the quarter miles and the half miles, this walking distance to the proposed platforms, okay? And we can enrich the data with also the population, demography, and job. So we can see in here, in the dashboard, all the households within quarter miles, and the job within the quarter miles, same household, but it says half mile, and the job half mile. How do I come up with this? This is all the analysis that available here in the GeoPlanner. The first one is using the using the proximity, create travel time. In this case, is the walking distance, and another one is data enrichment. Okay. The last thing that I want to do in here is the analysis of the development potential. So we're gonna take a look of the area near the ballpark in here. So we're gonna, the city of San Diego will build a few buildings replacing this some of the parking area in this scenario. So we're gonna choose another scenario, which is scenario we identify. And this is the proposed building in here. Okay. And then from the proposed building in here, we can actually calculate again the potential household, how many household and job will be available. So we're gonna take a look at these potentials. Sorry. The potential household is less than 10,000, And then the potential job is about 30K. It's still way below the target of City of San Diego. So we're gonna take a look what we can do to increase the value or the number of the household and the job in here. We're gonna compare it with the development potential. Okay. Now, development potential here is showing the area with the floor area ratio. It's kind of like a little bit hard to see in GeoPlanner with the 2D like this. So we're gonna move to another app. We're gonna go to ArcGIS Pro. ArcGIS Pro provides more advanced analysis and visualization. So in here, if I want to add data from GeoPlanner, I can easily just add the data, then connect it to the platform, the portal, and then choose my project in here. Oops. Let me just do this again. Okay. And choose my project in here. Okay. So it's seamless. It's all based on the same platform. It's based WebGIS. So we can actually get the input to GeoPlanner from ArcGIS Pro, and Pro as well can bring the layer from GeoPlanner. So in here, we can take a look the development potential, but now in the 3D. And you can see the floor area ratio. The darker one is the higher one, the lighter one is the lower one. Okay? We can even compare it with the existing building in the city of San Diego. So when we compare it like this, then we can take a look. Some of the building is actually a lot below the floor area ratio that's been assigned for that area. So it's more development opportunity in this area. So let's take a look in our proposal in here for editing. So we have in here several buildings that we're gonna edit. And it seems like it's still below the floor area ratio. So I'm gonna do editing a little bit in here and see if we can improve the situation. I'm gonna select this, do the attribute. Oh, the FRR is only 1, so I'm gonna bumping up to 6, and then change the height into 240. So it's really kind of like high-rise building in here. Okay. Okay. So let's take a look to the back to the GeoPlanner and see if it's improved the situation. So again, I just remind you, the existing situation is we only have less than 10,000 for potential household, and then 30K for the potential job. So I'm gonna refresh this dashboard, and now for the potential household, it's increased to become 35K, and then 105 for the job, which is very close to the target. This is show the capability of the GeoPlanner for ArcGIS. So let me just do the conclusion in here. GeoPlanner helped implement GeoDesign. With the GeoPlanner, planners are working smarter together because they can improve the collaboration. Again, GeoPlanner is designed for many different industry and disciplines. It's not only for city planning or urban planning. Okay? It's actually designed for non-GIS users, for easy to use. It's actually GIS tool for everyone. A little bit road ahead for GeoPlanner. GeoPlanner is a premium app hosted in ArcGIS Online and portal for ArcGIS. In the release of 10.5, GeoPlanner is embedded in portal, meaning you can just simply enable GeoPlanner once it's purchased, so you don't have to install again. In 2017, we will bring 3D visualization to GeoPlanner. We will also include advanced and more precise editing, and we also allow you to create online template authoring within the GeoPlanner environment itself. Okay. So together, we can create a better future for our world. GeoDesign helps to accelerate our understanding and inspire design and decision-making everywhere. Think what GeoPlanner can do for you in your own field, in your own organization. Thank you.